Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And the topic today again comes from one of my subscribers. I actually took all the suggestions and put them in a spreadsheet, and I'm just working my way down the list. And what this person wanted to know was more about atmospheric rivers, which is a fairly recent term in the meteorological field. It came about in the mid-1990s, and it had to be defined in a unique way because there were other terms that people thought maybe described the same thing, but they really didn't, okay? And so there was a study done at MIT back in 1994, and that's when this term really was born and officially defined. So let's go on ahead and talk about these atmospheric rivers, if you will. And I just need to click up here, and there we go. So the definition in the American Meteorological Society glossary, okay, is a long, narrow, and transient, which means that it moves, corridor of strong horizontal water vapor transport. So this is purely a horizontal phenomenon where you are transporting water vapor either in the XY plane or or in the XY plane, either west-east, north-south, whatever, but it's not three-dimensional. It's not transporting water vapor upward, okay? There's another term which has been in existence for a lot longer called a conveyor belt, and that is also a way to transport moisture, but it's three-dimensional. It may start in the low levels of the atmosphere and transport water vapor higher and higher as you head to a different location. So the two are unique in that sense. The conveyor belt is three-dimensional and the atmospheric river is more or less two-dimensional. On average, and by the way, just about everything in science is defined metrically, and so I converted those to English units so that it would make more sense. But on average, more than 1,245 miles long, less than 620 miles wide, and about 1.8 miles in depth. Okay, so it's near the ground. It doesn't really go up into the jet stream level or anything like that. Atmospheric rivers are the largest transport mechanisms of fresh water on the entire planet, transporting on average more than the Amazon River, which transports water at an astounding rate of 219,000 cubic meters per second, okay? So these rivers are pretty darn efficient in terms of transporting water vapor from one location to another. Again, the term was first used in 1994 via a study done at the Massachusetts Institute of Technology, and typically at any one time, 3 to 5 such rivers exist in both the northern hemisphere and the southern hemisphere. So right now, there are 3 to 5 of these things in existence in either hemisphere, okay? So it's not an uncommon thing, I guess what I'm trying to say. All right, so here is a two-dimensional look. This is like you're looking at a weather map, and you've got an area of low pressure up here. You've got an occluded front, which basically means that it's turned into a cold front aloft. There's no longer much temperature contrast near the ground. And then this is what we call the triple point right here, where the occluded front, the warm front, and the cold front all meet. And the cold front extends off to the south and west, the warm front off to the south and east. And right ahead of the cold front, in this area here, you have what's called a low-level jet. And by low level, I mean in the lowest, 1.8 miles of the atmosphere. And the moisture transport or water vapor transport is higher there with those stronger winds than they are anywhere else along that overall flow ahead of the cold front. Now this is a three-dimensional look here, so you're looking at the atmosphere from the side. And by the way, cold fronts do not go straight up and down. They're actually tilted back or slanted back toward the cold air. So this is the cold front right in here. This is the cool air behind it, the cool, dry air behind it. And then ahead of it, this is the warm air. And up here, you see this 60? This is at the jet stream level, and that's about 60 meters per second, which is over 120 miles per hour, okay? Then the winds decrease as you get closer to the Earth until you get down in here, in this lowest 3 kilometers, or about 1.8 miles. And here, you've got a low-level jet, which is transporting water vapor in the lowest part of the atmosphere, more or less in a horizontal sense, okay? So these usually occur just ahead of these frontal systems. In most cases, they're cold, but they can be stationary as well. Okay, and here is a satellite image, and this basically shows 2 rivers that existed on May 4th and 5th, 2009. Now, satellites can not only take pictures of clouds, but they can also give you values, estimated values of different parameters. And we've talked about precipitable water before, where you basically integrate all the water vapor in the entire atmosphere from the bottom to the top. And of course, there's a lot more of it in the low levels than there is way up high. But you integrate that, add it all up from bottom to top, and that gives you the amount of water vapor present in the column above you at any one given point in time. So this is what this product is, and you can see one atmospheric river going almost the entire way across the Pacific and coming into central and northern California, and then another one from off the southeast and mid-Atlantic coast that goes all the way up into the North Atlantic and almost gets to the United Kingdom. So these things are very, very long. And the one thing that's worth pointing out about California here, these atmospheric rivers are responsible for the majority of their rainfall. I mean, they definitely have a rainy season and a dry season, and if they don't get whatever rain that they are quote unquote supposed to get during the winter season, that creates a real problem out there with regard to their water supply, okay? So they rely on these atmospheric rivers to give them enough rain during the winter season to last them the rest of the year when not a whole lot actually goes on in the rainfall department. Now, there's a happy medium here where they want to have enough of these atmospheric rivers to give them their water supply, but they don't want so much of it that they end up having flooding and mudslides and all that kind of thing. And I'm sure you've all heard in the news over the years that they can do exactly that and cause all sorts of damage and flooding and so forth, and it's way overkill over what they actually need to maintain their water supply. So that is something that residents of California really watch every winter season, because they want just enough to help them out, but they don't want so much that they end up paying a big price for it in terms of flooding and mudslides and all that type of thing. Alrighty, that is bonus weather video number 3. I hope that was helpful. The next bonus weather video coming up Monday, the next daily weather update coming up on Monday. So I hope you all have a wonderful Friday evening. And by the way, when I was talking about the conveyor belt, I was just thinking as I have gotten older, my conveyor belt has gotten bigger and bigger, and maybe I need to figure out a way to make that conveyor belt a little smaller, maybe make more of an effort in that regard. But that's not a meteorological phenomenon, that's a human phenomenon. All right, getting back to that, I told you when the next videos are coming up. You all have a wonderful Friday evening and even better weekend, and we'll talk to you again on Monday. Take care, everybody.